If you have a multiple partitions, like more than one partition, so you could skip one partition, or you can include all the things. Okay, like that also, I would support. That is about the partitions. Any questions on the partition? Because that is a very commonly used way of um, designing your high table. So if the table is very large enough, okay, like people will always prefer, okay, like to partition the table. And the second one, okay, like people would be, most of the time people would be using about called bucketing. So what is this bucketing? um, the input data, okay, like will be further classified based on the column that you specified in the bucketing. Okay, like I will show you the syntax and all the things as well. So if I define my table by specifying that number of buckets as 3, so then it will be created like 3 different files. But folder would be the same, available in that partition, but the files data would be separated based on whatever the column value that you are going to provide. I'll show you that syntax information and all thing. Just give me a second. Uh, Okay, this is the syntax used for create table. Okay, like so, because it's very easy to explain using using the language specifications in the high manual. So create external. We already know that what is a external, or what does the external means. Similar to the external, there is a concept called temporary table as well. So it's a similarly, you could use any other um, any other databases like MySQL, Oracle. MySQL also, I'm not sure whether it has temporary tables, but Oracle has a temporary table concept, right? So if you define a temporary table, the table would be available only for that context. Once you come out from the context, table will not be available. Table will be permanently deleted from the Hive metastore. So how to create a temporary table? Add a temporary keyword, okay, before this table keyword. So create temporary external table, okay, like if it is there, and you could also mention about if not exist, then it will create the table if the table is not exist, or else it will not create. DB name, we already know that, and dot provide, and then table name. Okay, like so, DB name is which database that you are going to create a table. Font size, let me increase that. Okay, is it clear now? Probably. Okay. So create a table if not exist, a database name and table name. So anything, okay, like which is placed in square brackets is an optional. So if you want, you could give. Otherwise you could ignore that one. Okay, like so anything mentioned about in the square brackets, it's always optional. Okay. Next one is column name and data type. Okay, first you'll give the column name and corresponding data type here, and also you could specify the comment for a particular column. This is also very nice feature, only um, available in Hive. I'm not sure Oracle it will allow you to create a comment at the column level, but it does. Okay, like so. A column level comment and also a table level comment. Next one, partition by. Sorry, your voice is little low. Uh, okay, I increase the volume, but um, I'm not sure. Um, audio and video. Okay, let's see if it is better, my voice. Next one, you can give partition by. Okay, here partition by, again you can give the column name and data type. These columns are different from the from the columns which are available in the table. They would be called as a virtual columns or partitioned columns. The concept is same. Okay, like so. They're not the data, but you could define these columns on top of the data. Okay. Um, and the next one is called clustered by. So this clustered by is related to the bucketing logic. Okay, like so. And further, okay, like the table and a given partition, if you want to um, use bucketing logic, so bucket by, I mean, here the clustered by, and you could specify the column name, which is already given here, and then sorted by column name. So when you're specifying clustered by and also the sorted by is again like optional. Clustered by and sorted by, you need to specify into number of buckets. I'm not sure whether. Uh, ah, interesting. Let me try to copy this over. Okay. Um, I'm not sure again it will be visible or not. Okay, I'm increasing the font. I hope it's visible. Okay. So here, whenever you use the clustered by, there is an optional sorted by statement. Most of the time, people would use both clustered by and also the sorted by, and then into number of buckets, to 10 buckets, into 30 buckets, like that. So that is the reason this entire statement is used only for the bucketing. Um, how does it help? When you are looking up some value like any of the ID, okay, like so Aadhaar ID, your passport number, okay, like so, which is very unique and for a particular and that particular customer, particular record, and then you are looking up, okay, like you have been using in the joining conditions with any other table where A dot Aadhaar ID equal to like some other table that Aadhaar ID or something like that, like where you are defining your joining conditions. Okay, like so for that, if you define cluster by using that column, which will give you the better performance further. I mean, always it's not advisable to insert more number of buckets. Okay, like so, but you need to see that significant amount of buckets, and so that like each file in the after bucketing will have a significant size. I mean, significant size in the sense each file should be um, near to your block size like that. Okay, like if your block size is 128 MB, in the hide, whenever it try to read, okay, it will try to read the entire block of data. So if you have a very small files like one megabyte, 2 megabyte, 3 megabyte, maybe that is not a good idea. Okay, so this is the statement used for the packaging. If you say insert it clustered by, um, clustered by and some column names and into number of buckets into 10 buckets means into 10 buckets means there will be 10 different files will be created at the time of loading the data. It will be always 10 files for that partition. So there won't be any change in the number of files. Okay, that's it. Uh, mm, yeah. How does it calculate the bucket to which bucket that will be grouped into? So dynamically Hive will compute hash code of that column that we specified here, or combination of the columns, and using that it will um, it, it will allocate a particular bucket, okay, to insert the data into. Next one is another very interesting feature is called like screwed by. So here another one is called like screwed keys and unscrewed keys. So Hive also has these two features as well. Okay, like screwed keys and unscrewed keys. Okay. Here you could specify that screwed by and some of the column names and corresponding column values as well. So these two things, these two lines will be applicable only for the screwed by. Um, like screwed by will be used some of the um, uh, valid data only for a particular rows. So the data would be very much sparse. So you have, like for example, you have binary matrix. So if you are storing zero or ones, there are all the zeros. There are very a few places there are ones are there. Okay, like so that kind of a data if you want to store, you could use screwed by. Okay, like so screwed by, you could specify not only one column, you could specify the multiple columns here, column one, column name, column one, column two, column three, like that. And whatever may be the column values, whether it can be zero or one, or whether it can be some ABC or DEF, whatever it is values. So you could specify that one as well. And this these values you can specify more than one site. That's about the screwed by. Okay, like so. And next one, um, row format. This is also this also very important. Row format, and then you could specify the format of the data. Here, go to this row format wherever it is been defined. Um, Defaultly, we could use row format delimited because we are telling the high the rows have been delimited and fields terminated by. So this is how each column is being separated by in the input file. If you want, you could specify the escaped character, okay, like that. Next one is collection items terminated by. So when we created an employee table, I have shown you exactly like how and how the lines terminated by. These lines, each line corresponds a row. So if each line is not terminated by line field or slash n, you could specify that character by, by defining a lines terminator. Okay. Also, recently they added like null defined as what character that you want. So if it is a null inside the data, okay, like so, if you want to specify some particular character like empty, like space, called a new LL like that, you could specify that null defined as character. It will allow you only single character. It will not allow you to have more than one character there. That's about the row format. Um, but some cases, what would happen is if you need to define your own format of the data, okay, like then in that case, you could define called a survey, okay, like your own survey and then your survey name and what are the properties related to that survey, okay, like you could pass it using the row. In case of customizable format of the row. Next, go back again. So we finished the row format. Next one is stored as. Stored as, if you don't specify the stored as, okay, the default format is a text format, stored as text file. There are a lot of other types also provided by the Hive. So you could store all your data in the sequential file format. Sequential file is the binary file, okay, like binary format. Uh, uh, Anything you want to store it as a sequence file, you could do that one. Text file is the default one. RC file, RC stands for row columnar file. This is the a old version of the ORC. ORC is the one which is very optimized row format and which will give you a better performance than any other like text file, sequence file, RC file, like that. Another one is like Pocket. This is also um, very important and also which will give you the high performance. Both ORC and Parquet, they will give you the high performance when you define your table in these formats than text file. Both the ORC and the Parquet. They're not compete with each other, but they both are provided by different organizations and they are all open source and people would use it both the formats. Um, the Cloudera vendor, okay, like I'm sorry, the Cloudera vendor they supports Parquet format a lot. Hortonworks they support ORC, okay, like that. I mean, both are good. I have used it in both formats, and both has pretty much similar characteristics. So, uh, at least if you use one of these ones, that would be good. Avro is also another standard format. Okay, like uh, um, we'll talk about that one like more detailed. Okay, whenever we're discussing about the Avro. Avro is also another kind of a. This is also columnar based. Okay, like all the column, all the data related to one column is stored in one place. Um, Last one, you could specify your input format. Okay, like so, but if you define your own input format data and output format of the data, okay, like you could also specify that in the file format by specifying the input format and output format. Next, um, stored as we already given. Okay, like so if you have the stored by, and also you could give your own side parameters. That is also fine. Then the next one is the location. So where is the location of the data? Of course, this is only available in the Hive. So it will allow us to define our Hive table after loading the data. Okay, so that is one of the advantage exactly. So either way, it should be fine. So whether data would be available at first or definition is available at first, either way it will work. You specify the location. Location will always be pointing to which data path. And after the location, you could specify some of the table properties. Okay, like so uh, especially when you're stored as VRC or stored as Parquet, people use this table properties, okay, like to specify that if they want to compress the data on top of that, okay, like there are some kind of a parameters like that. So it will be always like a key value pair, okay, like key equal to value, like that, key value pair, okay, like always the property values will be. That is the next one. So all this one you could also specify and also you could say as select statement. So if you already have a table and using the table you could say like it's called like CTAS, create table as select, CTAS, create table as select statement. So create all the table and then you could add at the end as select your query whatever it may be, as select a star from table, select column 1, column 2, column 3 from the table like that. You could specify whatever the way that you want to. So it would work. How to create a temporary table? Okay, like create temporary table. If not exist, it will be the database name and table name. Like any existing table, location will be the HDFS. So if you already have a one table and you want to define another table similar to the table one, okay, like then you could use like this, like syntax, create table like. Okay. Some of the data types, um, data type, map type, struct type, union type, row format, file format, and other. So we already discussed all this. So here, this cluster by syntax will be used. Also, like if you want to define your own. Bucketing will be added only to increase the performance. Okay, like so Of course, partition is also like that, but sometimes partition would also help to aggregate the data at some particular level. Okay, like so. But bucket, most of the time, it will be used only for the to increase the performance of the table. So this is the overall abstract of the data stored in Hive. Um, some more detail level bucketing. So it will use the hash code, okay, like to get the particular bucket value, okay, like, and then it will couple. I mean, it will be stored in that bucket. So first, like clustered by, if you define some columns, then it will try to compute the hashtag of that columns, and then it will get the value, and then using that value, okay, like divided by the total number of buckets, it will get the bucket number, and then it will store into that particular bucket file. Most of the time, people would use both bucketing and then along with the sorting, so that it will be a very easy or even to look up particular bucket. If it is sorted, if it is sort, then I would know that where that bucket would be stored. Schools, I already explained this one, right? Okay, like so, it will uh, uh, splits out the values. What are the particular values that you are being provided as part of the definition, and it will create a separate files according to that. Okay. So most of the cases, it will be used when certain values are frequently seen, like binary matrix, where you have like sparse matrix, not the binary, sparse matrix, where you could say like you have more number of zeros and very less number of ones. So to store that kind of a particular data, you could use this code by replication factor. Uh, Sometimes people define or increase replication factor, okay, like from default 3 to 5 or 7 or something like that, okay, like so. What would happen is if you increase the replication factor to 8, it will keep minimum 8 copies of the data at different nodes. So if I have 10 data nodes, so if I increase my replication to 10, that means almost all the data nodes has the copy of that one. So whatever the data node, okay, like which is ideal or which is available for the resources, so you could run the queries against the data which is stored in the locally. So that is the one kind of an advantage. People bump up the replication factor if they want to. Sometimes this is also like one kind of a tuning mechanism, okay, like how you tune your data, okay, like, but if you have 20, 30, 100 node clusters, they don't do that, but very small clusters, they will do this one to increase the replication factor. Sorting, um, most of the cases, sorting would help when you are storing the data itself. If you sort based on some columns, so that will always improve the performance. Also, like it will um, will allow the Hive, okay, to move the data um, uh, depending on the sorted values. Also, when you are using a stored as ORC, okay, stored as ORC format, you could also define Bloom filters. It's called like there are some kind of a filters, okay, like you could define. You use a particular column value, okay, like when defining this Bloom filter, which will be further be used a lot, okay, like when you're looking up some data. Again, I have given all the built-in formats like delimited text, ORC file, RC file, Avro, Parquet, regular expression. We already covered that. Table versus external table, I think we already covered in the last class itself, right? What is managed table? What is external table? What would happen um, if you delete, or if, sorry, if you drop a managed table versus if you drop external table? Okay, like so, we'll go through that one more time. Very, very important. And um, when you are going to face an interview, most of the interviewers, they will ask this question. So it's very, very important. I think This is the most famous interview question in the Hadoop, okay, like in the Hadoop side. Um, Difference between a managed or internal table versus external table, or managed table versus external table. People would use internal table, managed table, okay, interchangeably. The default type that Hive support is the managed table, okay, like so. If it is a managed table, it will be treated as a temporary tables only. That means whenever you delete the data, whenever you drop the table, the entire the data would be deleted. Okay. If managed table or its partition is dropped, the data and metadata associated with the table or partitions are deleted. So it does. If any other table defined using the same location, even the table won't be able to query that data, because whenever you drop an manage table, so it's the data corresponding to its location will also be get deleted. Okay. Uh, yeah, initially when you drop the table, all the data also would be moved into the trash folder. But there is an option called purge when you select drop table, purge or something like that. There is this. So if you use that purge option, okay, it will delete permanently. It will not even move into the trash. Next, external table. As the name indicates, external table, it will be managed by the processes outside of the Hive. So Hive will not maintain its location, and it will not keep track of where the data has been located and all the stuff. So how to create an external table? So add the keyword external in create table statement. Okay, like so. This is the most recommending approach to create tables in Hive. Okay, like so. Yeah, I mean, sometimes people would use managed tables as well. Okay, it's not that every time we use it, but there is a danger if you define a managed tables. And if external table is dropped or any of these partition got dropped, the data associated with the table or partitions will be preserved as the table is maintained outside of its cluster, outside of the Hive. External table will allow us to create multiple tables pointing to the same location. Okay, like so, and there won't be any risk of losing the data at any time. So, in any case, if you are defining a multiple tables pointing to the same location, it's always recommended to use define as an external table. How to see whether the table has been internal or managed or external? So you could use the syntax command called describe, formatted, and then table name will display you whether the table is internal or external. Describe, formatted, and then table name. Okay. Next one, we'll see that like for what kind of a data Hive is not suitable at all. Okay, like which table or what type Hive does not support. Okay, like so. First thing, any transactional related data. Okay, like Hive is not a good ideal case. Okay, like to go with that one. Any OLTP loads, like any OLTP related loads or um, um, any transaction based data, okay, like Hive is not the good candidate. Next one, if you are expecting a very low latency from the results, okay, like then Hive is not a good ideal case. So if you are expecting a microseconds, okay, like that, don't go with the Hive. Hive will not give the low latency. Hive will always give you more latency than any other tool. If you want to write very closely related, okay, like subqueries, okay, like so Hive is not a good choice if you want to use it as subqueries. Like select a star from employee where city is in select a city from other table like that. So if you can define the subqueries, but Hive will not perform well when you define a subqueries. Another one, a high performance will be degraded. Okay, like when you're looking or when you're using a very small amount of data. Suppose in a high table, if there are only 5 rows, but still you could see that it will take a very long time uh, to retrieve the data from that 5 rows table. So Hive definitely has a lot of overhead. Okay, like in running your job, getting the results, and display to you and all the stuff. So when you're testing, when you want to test with a very small number of data elements, definitely Hive will not be a will not give you the good performance. But when you're dealing with a very large amount of data, significant amount of data, then Hive will perform perform very better way. Partitioning, I think we already talked a little bit on the partitioning information. Uh, when you define when you partition a table, definitely the queries using the table will run much more faster way. Okay, like when you're defining a partition, it may involve more than one columns. So you could define the partitions or multiple partitions. You need not be only one partition. You could say n number of virtual columns. What virtual columns has partition column? How to define a partition? So here you could see this one example. A create table, sales table. It has two columns: ID, amount, and some columns. You could define partition by, and here sale date and then state. So these two are virtual columns. These are not part of the data. Okay, like so this would be apart from data. Okay, like you could also define some other columns, okay, which will have the common data for across all the elements of the table. So that's why they've been called as the virtual columns. So here the sale data and state are not the real column names, so they are called like virtual columns, and then also of course they are also called as the partition columns. When you define your partition column or virtual columns, okay, like so, they will cause to create a different directories in HDFS. So each table will be pointed to a HDFS directory, right? So under the directory, okay, like if you have a two partitions, there will be two more directories will be created, and then data will be separated as per that. Okay. In that case, typically whenever you are providing a partition column values, so your input data size will be reduced and your query will run much more faster. So that is a advantage. Okay, next one about joins. Uh, very important in the joins because when you have a very large number of rows in a particular tables, and like million rows versus million rows, and if you're trying to join these two tables, you will see a grateful degraded performance in any of the SQL databases. You just name a database where if you're joining a million rows to the million rows table or 10 millions versus 10 millions, you will not see the results in less time. You will always see they will take a very long time. See, but of course, in Hive, definitely like there is you will get it in less times in that cases, especially about million rows, million to million. First, let's see that first of all, what are the joins, and I will address all different types of joins. Because when you use the like SQLs, right, like SQL join is very common thing. Okay, like so if you have a good hands-on on the join, okay, like so in Hive, if there is any complex thing to learn, it's only joins, nothing else. Okay, like so. Again, Hive will follow the ANSI SQL standard. Okay, like so. If you are familiar about writing ANSI SQL and joining multiple tables, then you already know the syntax. So there won't be any big difference on the syntactical part. So here in this slide, okay, like we do have two tables. One is called like customer, and another table is called like order. Customer table has first name, last name, and then particular ID, and then order table also has a customer ID and then corresponding price and what is the quantity that they have been ordered in that order. Okay, so here if you see closely, um, a given order ID from a customer table will have more than one entry in the orders table. Okay, like so here 11914 is the order ID, and then you could say In the order table, you have more than one entry here. There are two entries for which are matching with 11914. So if you want to join these two tables, both customer and order table, it says select a star from customer and then join order. Here, customer join order. Remember, the join keyword is in between the two tables. One table is called like customer, another table is called order. And then join on what? On which condition? So the customer.id equal to order.cid. So this is how you would write join statement. This type of a join is called like an inner join. Okay, like I will come on this strategies. Okay, like let me explain here what would happen. Uh, maybe okay. So this is what like how you would join. Okay, like there are different kind of a joins. Okay, like our left outer join, right outer join, inner join, and this is called inner join. Okay, like so. Um, but the next one at the high level, okay, like so, what type of join that high would support, and when what are the advantages of that particular join or the disadvantages and way to use it. Okay, like so, three types of join at the high level. Okay, like so, one is called like a even though inner join, left outer join, right outer join, there are like what do you say like different join methods. Okay, like but this one are types. One is called like a shuffle join, broadcast join, sortment bucket join. Shuffle join, okay, like here, how it will perform when you give the keyword as like a shuffle join. Join keys are shuffled using map reduce and join performance and joins performance join side. So all your keys, okay, like so what are the keys here? Like here in this previous slide, here the key is called like ID, customer data ID. So what are the distinct values of that customer data IDs? Okay, will become a keys here. They are the joining keys. Here the customer.id is a join key. Sometimes it may be more than one column where you will join. So that keys, okay, like will be typically shuffled. Okay, like shuffled means it's just like randomly distributed. Okay, like you mix it up and then like randomly distributed that one. Using what are the map reduce one and then like you join performance. You join according to that one. So it will work regardless of the data size or layout. Sometimes some particular joins will be useful whenever you based on the data size. Okay, like if you have very less data, then you go with this, and if you have, but shuffle join will work whatever the regardless of the data. But when you define your join as a shuffle join, it will be most resource intensive, and it's very slowest, and it will run very slow. Sir, is it join side or reducer side? Is it join? It's a like map side join or reduced side join. Okay, like so that's, I think maybe you're asking me that like whether it will be a map side join or reduced side join. Okay, like so. Most of these joins, okay, like shuffle join, broadcast join, or sort margin bucket joins, they all would work on the reducer side, not on the mapper side. I will explain that what is a map side join and where you will use it in the coming slide. Next type is called like a broadcast join. Okay, like so broadcast join as the name indicates like one of the table they will try to broadcast, okay, like to all the nodes it will be running on. So typically small tables loaded into a memory in all the nodes and then like mapper scans through the large table and then joins. Okay. Um, you broadcast joins are very fast and single scan through the latest table or whatever the was. A single scan through largest table. So largest table they will keep it in MapReduce thing, and the smaller table they will try to store in the memory or it's JVM space allocated, and then like it every time it will read from that one. Okay, like so. Um, but the constraint, okay, like on the broadcast joiner, okay, like all but only thing is only the small table should be enough to fit into the RAM allocated for that, allocated for your um, yarn container or whatever it is. So if it is not able to fit into that one, again you cannot use the broadcast join. So even though you use the broadcast join, if the table is not able to fit into the memory, then there won't be any use by defining a broadcast join. But if it able to fit into the memory, and then your joins will run much more faster. The third type is called like sort merge bucket join. Okay, like so. Uh, Here, okay, like so, when you're doing this map ready jobs, the mapper take the mapper parts, which take a greater advantage. Okay, like because all the keys will be sorted out, and also it will allow them, okay, like to um, what do you call like to divert all the data related to the keys at a particular reducer, and then like so your join will be much more faster. So this will also very fast for tables of any size. Okay, like typically when you use the sort merge bucket join, will give you the better performance. Okay, like only the consent or your data should be sorted out and bucketed ahead of time. So this is to take advantage of this join. People defined bucketing on when they're defining a high tables. So when the tables are being really bucketed, then you could use like sort merge bucket join very easily. Okay. I have slides also how to use these all these different joins. How to use how the shuffle join really perform for the same example, or like what are the things that we have, or what are the example that we looked at here. Um, for a customer Roger, okay, like his ID was 11914. Okay, like so whenever you are joining between the customer table and order table on customer.id equal to order.cid. So let's see that what would happen at the mapper part, what will happen at the reducer part. In the mapper side, ID equal to 11911. Okay, like and then first name, Nick and toner, okay, like it will be passed, and ID 11914. First name is Roger, last name is this one, so it will be happen at the mapper side. But when it comes from the mapper to the reducer, what it does is it will try to get all the keys like 11914. So all the entries from the mapper with a similar key, it will try to go to that reducer. For entries, okay, like will come to this reducer. So this is what like it will happen. Identical keys shuffled to the same reducer. So the join, okay, like done at the reducer side here in this case. Because you cannot do the mapper side joins with this method. Okay, so on the disadvantage side, you need to all this data would move from one node to another node. Okay, like so there is a lot of um, network will be utilized or will be used. Okay, like when transfer the data between from mapper to the reducers and all that stuff. Broadcast join. Okay, like so where I think I do have that one too. Okay, like so. Um, Sometimes when you have a star schema like that, when you define all your databases and schemas, so when you have some dimension table or fact tables, people would term it as a dimension table and fact table like that, especially in the star schema. There will be a one fact table and there will be like very small number of dimension tables. Okay, like where some of the columns will be derived from or inherited from the dimension table. So here, this dimension table will be very small. So typically they will be fit into the RAM. So small table held in memory. Okay, like so uh, they will be for that kind of a table. If you are joining, then you could define it as a broadcast join. Then sometimes when both tables are too large for memory, okay, like so none of the tables would fit into the memory. So for that kind of a cases, we cannot do anything. So here, instead of having a regular shuffle join, so if you define here, for example, here the order table and customer table, they both are defined as clustered by CID here for the order table, and ID will be the customer table sorted by CID into 32 buckets. Here also the 32 buckets. So all the data, okay, like based on these IDs, okay, like so it will be placed into 32 different files underneath. So when you are sorted by the 32 buckets, so the lookup would be much more faster. And when you are joining between customer data ID equal to order.cid, your query would run very, very faster than the first case that we explained. So that is the advantage. Okay. But all the joins would happen at the reducer side only. We'll come back on the map side joins. Okay, also. I think I do have some slide on that, but if not, like I'll try to add on that. Okay. Um, some of the guidelines, okay, like especially for designing your Hive table or Hive databases or architecturing your Hive database. Um, when you have the table size is very, very small, okay, like small size, okay, like then um, uh, what are the type of the query pattern that you could use it? So if it is very small enough, so you could increase the replication factor so that data would be available in most of the nodes, so that like it uses the data locality, okay, like data locality principle, and it will run much more faster. So because if the data is available in the local, then it will take much time to read from the local disk than from the remote node. So that is the purpose. And any table size, and if you are very um, if you have very precise filters like state ID equal to AP, state name, or the state code equal to AP, like that. If you know that a particular very precise filters, then most of the people what they do is like they'll define the sort by of that column. So when you're looking by sort by of the state code, okay, like so if it is value is AP, then if it is already sorted, then your lookup will be much more faster, okay, like than unsorted columns. When you have a very large set, okay, like and your profile would be anything, and when you are joining with another large table, so sort and bucket on both tables would give you the better performance. Okay. When you have a very large set, okay, like one value is greater than 25% of count of within the high coordinate column, so your values will have very much sparse. Okay, like so. I mean, only you have 25% of the rows only will have the valid values or something like that. Okay, like then you use that. You define the table as a scoot table. Like you define the scoot by and then column names, column values, and like Uh, large tables and queries tend to have a natural boundary such as date or something like that. Like when you have when you could able to um, define some boundaries for your data, like year, month, date, and type of the product. Okay, like that. If you can define that boundary very clearly, so that the data within that boundary is nowhere related to the out of the boundary, then you define a partition on that table. Okay, so they are the principles need to follow. Um, Data layout considerations. Okay, like to increase the performance of the Hive. Okay, like so partition tables. Okay, like partition is definitely increase the performance because it will skip most of the data to read. Okay, like so that is the main advantage. Uh, when you are defining a VRC file, you could also define as a secondary column, so like sort by some of the secondary columns that also increase the performance because that will skip the reading of set of values of the a particular set of the values. Okay, it will skip the reading while reading the data itself. Next one, if you want to minimize the shuffling. So these are the things like, I mean, whenever you run some Hive query, okay, first thing is you need to see where it is taking the time. Okay, like whether it is taking the time at the reading the data, or whether it is taking the time at the shuffling phase, whether it is reading the time on the reducer phase like that. So find out where it is taking the more time, then it will allow, then you need to go to that particular section and tune that parameter, okay, to increase the performance, okay, like so. First we need to see that where it is taking the time, then only it will allow you to tune further. Suppose if the shuffling is taking a more time, then if you want to minimize the shuffling time, then both the tables, okay, like A and B tables, okay, like can define the bucketing on the common keys, and then play around with the number of buckets, okay, like, and then you see that one, how does it will help out. Second thing, if you want to minimize the shuffle time, so if the one of the tables is small enough to fit into the memory, then you define the broadcast join. If you want to reduce the latency, okay, like so, if it is taking a more latency, okay, like because the cluster resources are not available and it's reading the data which is stored in the remote node. If that is the case, then increase the replication factor, okay, like, and uh, short circuit read, we need not enable it. Default it's unavailable in all the high versions, okay, like so. We, we need not do anything in this explicitly. And there is a framework called Tej. Okay, like Tej, contrary to the traditional map reduce, it has a very um, improved execution engine. Um, it will avoid some of the unnecessary steps in the mapper and reducer phase. So it will optimize the DAG, okay, which will be created by the high framework, so that like the number of mappers and reducers run using the Tej framework will be very, very less when compared to non-Tej frameworks. Okay. So that is also one way, okay, like to increase your performance. Make sure that your queries would run using Tej framework. Okay, that is the default thing. Just change execution engine as to the Tej from MapReduce, so your query would run much more faster. I can also demonstrate, but we'll see that, okay, depending on the time. Okay, yeah, regex column specifications. This is very only available in the Hive. I mean, yeah, typically uh, in recent days, okay, like some people are asking about this question in the interviews a lot. If you have 100 columns defining in 100 columns available in a one table, how could you avoid some columns? Okay, suppose say like I do have 100 columns in a table, like column 1, column 2, column 3, column 4, like that up to column 100. So here, here the interview question would be, how can you avoid all the columns starting with column 9? So you need to select all other columns other than column 9. So one way, regular expression syntax. Here, select, and here I've given like DS, HR from sales. So from the sales data, from the sales table, any column which is not starting with DS and HR will be be passed to the results. So any column with DS and HR will be excluded from the selected column list. So if you have 1,000 columns and you want to exclude only 2 columns, you need not write all 998 columns in select statements. So instead, you write the 2 columns and you use this syntax. You are specifying high that exclude these 2 columns or exclude the columns starting with DS or HR and bring all other columns. That's what it means. So when you use this regular expression using this backticks and question mark plus dot plus, that indicates that it will exclude the columns matching with the regular expression. It will help. Definitely, it will help. If you have like a 2,000 columns table and when you want to um, select only 100 columns, which has some particular pattern, okay, like then you could use like that. Yeah. Nowadays people are asking basically. Nowadays people are more. I don't know why they will ask, but I'll ask the question. But yeah, I heard from people that like how to filter out some of the columns from the select statement. Obviously, I'm not sure like how you do that in the Oracle or MySQL or Sybase. I don't think these databases will allow you will give you this much of flexibility. Okay, like towards your tables and all the stuff. I'm not sure whether really Oracle has any provision, okay, like to exclude some of the columns from the select list. I doubt. Maybe it may be available, but I don't know exactly. Next, um, word count. Okay, like you already saw that how to define a word count using Java MapReduce. Okay, like so. Um, Let me see whether I do have. Um, I do have a SQL program. Okay, like how using the Hive SQL, how to write a word count. Okay, like so. Um, I'll come back on this word count thing. Okay, let's skip and let's finish this next slide, and then I will come back on that. Maybe some of you, those who are very much familiar about SQL and PL SQL, maybe you might be wondering that are there any component where I could write my stored procedures using Hive? Yes, uh, there is a tool. It's called like HPL SQL. Okay, like it's called procedure SQL, which is very similar to Oracle's PL SQL or Teradata stored procedures kind of stuff. So where you could add cursor, loop, while loop, if statements, okay, likes, and also some of the exceptions. You could define all these things in HPL SQL. Um, it's not much famous. I don't know why people developer having only SQL skills. All right. If the people know only SQL, then only I will go for HPL SQL. If they have some other skills, right, like writing a Java program or writing a Pig script or writing any Spark program, then I could leverage them. Okay, like to write the similar functionality using Pig or Spark or Java, or like Java MapReduce like that. I need not write only HPL SQL. Okay, so that could be the reason it's not famous. But it's earlier days of Hive, it's not available. I think some beginning of last year only it's been added okay, to the Hive suite. I think so. Um, so yes, Hive has uh, SQL, like Oracle PL SQL or Teradata stored procedures like that. So uh, it has cursors, it has the loops and all the stuff. Like so, if any people ask you, okay, like so you could also do that. I am not a good expert in HPL SQL, okay, like, but I want to tell you that yeah, there is a way, okay, to do that. Next, high word count. How to define high word count? I'll show you that. One second, let me see that one. Sir, one doubt in general means optional. Um, I'm sorry. Jane, to you, Vijayanagaram, one more time. Could you explain me your question? Maybe you could unmute your. Let me unmute you, okay, so that you could talk.
Sir,
Yeah, I'm able to hear you.
sir, sir, in regular expressions, question mark means optional.
Oh, here. Uh, in general, no, I think here, yeah, again, it's not a Java regular expression or even a parallel regular expression like that. It's a high regular expression syntax. Okay, like so, um, it's been added from high 13 or high 14 onwards. But this will this syntax will exclude DS and HR columns or any column which is started with DS and HR. This This is like pipe is look for R, and your bracket will, if you have more than one entries, you could specify that brackets there. And this one, I'm not sure whether it is beginning or ending or something like that. Like, yeah, and then plus dot plus. They don't have much options exactly. Like, I don't know why the five people have chosen this syntax and okay, like so it has um, uh, very peculiar syntax. Okay, like it will allow you to only exclude some of the columns. I'm not sure how you could include only a particular set of columns exactly. For that, I think you could use a star. Maybe it will work. Okay, like if you can just say if you want to define all the columns which is started with the EMP like that, EMP underscore, you said to select EMP colon, EMP underscore, and then put star, and then from there like that, it will give you all the columns which are starting with the EMP. But there is no way that to exclude that. So they provided this one. It's not the Java regular expression or something like that. Okay. Broadcast join. Um, I don't have a particular example for that. Um, let me open that for you. Maybe next class I will show you exactly like how to define your broadcast join. You need to add some this one I guess. So okay, this is the one. I'll show you exactly like in the next class probably. Uh, this is also not the right way. I'll give you the next step. I have some other place. Okay, I have used in the work. Okay, so I will get the same example and then I'll show you in the next class. Any other questions? Um, Hive also supports to define your indexing. Not sure whether I do have a slide here. Um, Probably not. I just had here indexing, but I don't have much more information. You could also define index, index on the index in the Hive. So whenever you define an index, so it will create it will create a new table and it will store the index information, okay, like in the new table. So whenever you create an index, it will create another table. Typically, in any of the database also, it will store that all the indexing information in some table or some place or some storage area. But Hive, it will create another table simply. It will create a um, managed table for the indexes, and then it will put that way. Another one I want to show you exactly like um, Hive. If you have any of the XML files or JSON files, okay, like that. So uh, if you want to define or if you want to use SQL syntax based on the JSON file, traditional databases will not allow you to do that. Okay, like but whereas in Hive, you store all these JSON files into HDFS and then you define a SQL because JSON is not the default format that Hive supports. Okay, like you could easily okay like define the schema okay like using the JSON file and you write a small survey okay which would parse the JSON files and instead of transforming the existing JSON data okay like you could define sequels on top of that. So that is a beautiful feature of the Hive. So typically in the traditional world, it's very hard. If you want to define a SQL syntax, you need to transform the JSON data and then store it into a table or flattened table or whatever it is. So without transforming, Hive would give you that flexibility. So that is very useful. Unfortunately, I don't have that system right now with me, but maybe in the next class I will show you that like how to define a Hive table pointing to JSON, and also we will run a Hive word count. Okay, like here I don't have the Hive prompt here as of today. Somehow I'm not able to open my sandbox. That's the reason I'm not able to run anything. So on Thursday class, I'll show you broadcast join and I will show you how to run a word count using the Hive. Okay, like next thing is I will also show you how to create a Hive table on top of JSON. I have a small work today. I need some time. So if you don't have any questions, I would like to take sign off and I will leave 15 minutes early today. Okay, like so. Let me know for any of the things on the next week class. Okay, like we'll continue the Hive, and then if there are no more questions, then probably we'll we'll go to the new topic. Also, I'll show you exactly like how to run a Hive query using Tej, how to run a Hive query using MapReduce. I'll show you that one too. So the next week probably entire our time we will dedicate it to only the hands-on thing, and then I'll show you all the examples. Okay, like with that, maybe probably with this week, okay, we could close the Hive. I covered a lot of things. Okay, like so, this will be enough really. Any further questions? Okay. Thank you very much for joining today. Okay, like let's catch up again in the